Hello everybody, welcome back to Fun Science and Amazing Things. I am Aryan and today we're exploring quantum computing. Quantum computing is a technology that organizations like IBM and NIST say could transform medicine, AI and logistics and even breaking encryption. Stick around because by the end of this video you'll understand the four key concepts behind it all. Number 1, interference. Number 2, decoherence. Number 3, entanglement. Number 4, superposition. Before that, let us first understand how classical computers work. Classical computers, like your phone or your laptop, work using bits, that is 0 and 1. Everything you see on your screen or that you type is made up of long sequences of bits. Classical computers use logic gates, that is, tiny electronic switches to process bits. Examples of logic gates are AND, OR, and NOT. Everything you can see or recognize on your computer is made up from millions of these logic gates. Inside a CPU, there are millions of these logic gates. Classical computers may be extremely powerful, but they struggle when there are many possibilities because they process everything one by one instead of processing everything at once. That's where quantum computers come in. They use qubits, interference, etc. to do many possibilities at once, which reduces time. Some examples where normal computers struggle is simulating molecules and uh, inventing new ways for medicine cure. Now that we have learned about classical computers, let us learn about quantum computers. But first, let us learn what is a replacement for bits in quantum computer because they do not use bits. They use qubits. Qubits are like a replacement for bits because they can be at 0 and 1 at the same time. They do not take a certain value until measured. This is what allows quantum computers to process everything parallelly and more faster. Let us learn about the first quantum power, that is superposition. Superposition is like a spinning coin. Spinning coins are in both head position and tail position at the same time. They do not take a certain position until they are stopped and drop down. So, imagine qubits like spinning coins. They do not they are in both values at the same time and they do not take a certain value until measured. So, qubits are always in superposition. So, that's the first key quantum power. Entanglement. It's the second key quantum power. Entanglement is like when the sum of two digits is equal to some number. Let us say the sum of two digits equal to 50 and you measured one digit, that is 25, and now the other digit must also be 25, right? Imagine qubits like that in entanglement. If one qubit is measured, the we know the sum of the two qubits is equal to something, and we can determine the other qubit's position. Let us learn the third key quantum power, decoherence. Decoherence is like wind trying to make the spinning coin disrupt and land on the wrong side, like instead of tails, heads. We need to minimize decoherence as it is like disturbance to the qubits which can result in wrong results while computing. That is the third key quantum power. Now let us learn about the fourth key quantum power, interference. Think of interference as a, as streams. Streams are all the possibilities, whereas uh, junctions where the streams meet and form a river is for the right path, whereas where streams dry out and lead to nowhere, that is the wrong path. That is what interference helps in quantum computing. It increases the probability of the right path and decreases the probability of the wrong path. Now that we have learned the four key quantum powers, let us learn where quantum computing is useful. IBM and NIST highlight four major areas where quantum computing helps us with. Number one, designing new medicines. It can help design new medicines for cure, etc. Number two, accelerating AI. It can help develop AI and make it better. Number three, it can help optimize logistics, which is very good in terms of transportation. Number four is breaking current encryption because right now our data isn't safe. Now that we have learned the four key quantum powers and the four uses of quantum computing, let us learn why quantum computers haven't entered our daily lives. Quantum computers are still experimental. They need ultra cold temperatures to prevent the qubits from giving errors due to decoherence. And if qubits are kept at a higher temperature, then decoherence will make us give wrong answers. And qubits are uh, error prone when they are arranged in a huge manner. That's why we have only been able to achieve quantum computers with tens to hundreds of qubits. So that's all for today, guys. Please make sure to like, share, and subscribe to Fun Science and Amazing Tech for more tech and science breakdowns. See you in the next video. Bye.